This is the second video for section 2.6. In the first video, we talked about the rational zero theorem and what it means. This video is going to actually show you how you can use graphing and factoring to find all the zeros of a polynomial. Before calculators, what you would have to do to find all zeros of a polynomial is you would use that rational zero theorem. You'd list all your possible rational roots. And then you'd have to go through the list and try one and try each one until you found a zero. And if you found a zero, then you could use that zero to divide into your polynomial to get the rest of the factors. It kind of is like this. If you have a number like 24, okay, you know that 2 is a factor of 24, okay? 2 times what gives you 24? That's 12. You remember doing these factor trees? So if I give you 2, if you do 24 divided by 2, you will get 12, okay? And then you're like, okay, now can I break down this 12? Oh yeah, I can. I can divide 2 into 12. So I can do 2 into 12 like this. Oops, it's not really behaving here. Here we go. That's a 12. Yeah, that's a 12. There we go. And get 6. So you would have 2 and 6 here. And then you would just keep going, and 2 and 3 till you had it broken down into all the prime factors. And you remember doing this in pre-algebra. Okay, this is the same idea with these polynomials. But it's really difficult and time-consuming to go checking through list after list, checking through that list and using synthetic division to find the zero that you want. So what I'm going to have you do instead of going through that list is use your calculator. So you're going to be graphing these on your calculator. So when you graph them, okay, it's going to look something like this. Let me find, there we go. So here I've typed in that equation that I had on my screen into my calculator. So you'll notice that it's crossing the x-axis in 3 different spots, okay? Those are the zeros. Those are the zeros of your function. So what you can do if you can't tell what they are, I want you to just graph and find one. Okay, I'm going to pick this one. A little thing that you can try is to, excuse me, that's not what I want, is you can use the Analyze Graph functionality on your menu and do 0 and actually zoom in on a section and it'll show you the 0. So there's a 0 at 2, 0. So I know 2 is a 0 and I'm going to figure out what these other 2 are. It looks like they're at 1, 2, 3, 4, 5, 6, 7 and negative 1, 2, 3, 4 and negative 4. So I'm going to see if that's really what those are. So I'm going to take the 0, 2. I'm going to go back to my Zencora page. And it said 2 is a 0. It looked like 2 is a 0. So if 2 is a 0, then x minus 2 is a factor, okay? So what I really have to do is divide x minus 2 into that polynomial. But because long division is not fun, I'm going to use synthetic division. So I'm going to take my 0 and I'm going to put it right here and set up my synthetic division. Okay, so I'm going to put all my coefficients. I've got a 1, negative 5, negative 22, and 56. Okay, and I don't have any zeros I need to contend with. 3, 2, 1, constant, I'm good. I'm going to bring that 1 down. 2 times 1 is 2. Add my column, negative 3. 2 times negative 3 is negative 6. That is going to be a negative 28. 2 times negative 28 is negative 56. Now when I add that column, I get a 0, which is what I should get. Because 2 is a 0, I should get a remainder 0. So what I've discovered is x minus 2 is a factor from my graph. When I divide x minus 2 into this polynomial, I get x squared minus 3x minus 28. Because remember, these are the coefficients of my solution to the division problem. Now, let's take a look at this. Maybe I can factor this. I'm pretty sure I can. Okay, x, looks like a 7 and a 4. 7's got to be negative. The 4's got to be positive. So as you can see, the 3 zeros of my polynomial are whatever are going to make each of these zeros. Now we already know that 2 is a 0. If x is negative 4, that's also going to make that polynomial a 0. And if x is 7, it's going to make it a 0. So the 3 zeros are 2, which we saw on the graph, negative 4, which I'm pretty sure it looked like the other one was, and 7. Okay? Those are the 3 zeros. So that's what I want you to do for your homework. I want you to use your graph to pick one of the zeros, okay? And I know you can see the other zeros on the graph sometimes. Sometimes the graph is very clear what all the zeros are. But the reason I want you to practice this is not all problems will have beautiful little zeros crossing exactly on a beautiful integer. Sometimes that's going to cross at a spot that you can't tell what it is. It might be irrational, like a radical 3. It might actually be a complex number. So remember when we had parabolas and they didn't cross the x-axis at all, but it still had two solutions and they were imaginary? That's what could happen. So you might actually have a polynomial where it crosses the x-axis in one spot. So you see 1, 0, but the other solutions to the equation, the other zeros, are actually complex. So that's why it's important that you actually show this work and go through this process so that you can do it in case you don't have beautiful looking zeros like we did with this problem.